Assalamualaikum. My name is Muhammad Fahim Zulkifli. As you can see in this slide which is an abstract. The objective of this study is to determine the ionic conductivity and voltage stability of sodium polymer batteries. Organic polymers and their derived carbon materials are abundant in resources with a small environmental footprint and controllable structural design, and can be directly used in the positive and anode of sodium-ion batteries, which is of great significance for green and sustainable development. Organic polymers also offer great advantages in flexible sodium-ion batteries due to their inherent flexibility. The research progress of flexible organic polymer materials and flexible polymer-derived carbon materials in sodium-ion batteries is reviewed. Among them, flexible organic polymer materials will be divided into flexible organic polymer carbonyl molecules and their composite with graphene or carbon nanotubes. For polymer-derived carbon materials, we will introduce several different precursors and preparations methods, perspectives, and envision for the further development of flexible, renewable polymer. Okay, for the next slide is introduction. The sodium polymer battery is a battery rechargeable that works in our life. It had a high energy density, long cycle life, and can operate in harsh environments. For this reason, they can be found in application in energy from intermittent energy sources such as wind and solar power. A battery is a device that stores energy and then discharges it by converting chemical energy into electricity by chemical means through the use of one or more electrochemical cells. The battery is really crucial because it plays important roles in everyday life, from providing the initial power required to start engines of cars to acting as a backup source of electricity in telecommunication, public transportation, and medical procedures. Okay, the next slide is the researcher tried to alternate from lithium to sodium because sodium polymer battery become recommendation due to factors of their source is more abundant and low cost than lithium. Next, it also has similar chemistry and intercalation kinetics to that lithium. Moreover, it also better for long-term investment and lower energy density. However, every advantages will be have disadvantages, which is the thermal instability, potential leakage, and dendrite growth by sodium can cause a several limitations to this technology.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Imanizar and I will present to you about literature review. Polymer electrolyte can describe as ion conducting polymers matrix. Polymer electrolytes, like other solid polymer electrolytes, make it easier for charge to transfer between the anode and cathode of a cell. Electrolytes materials which are able to transport desired ion, such as sodium, and simultaneously block the diffusion of electron, are deemed as one of the most crucial components for high-performance rechargeable batteries. Apply to sodium batteries if LEs are used. At the end, the replacement of LEs with solid electrolytes has been since long considered and proven to be effective by the commercial application of polymer electrolyte-based solid-state batteries produced by the Boller Group in Article 3. Besides to the research, their main objectives is about to study ionic conductivity through 6 articles to gather the observation and value of each ionic conductivity they were obtained to our research. There are varieties of value was obtained. Each article states clearly ionic conductivity with variety weighted which is their value is 3.6 times 10 to the power of negative 3 s per cm, 1.5 times 10 to the power of negative 4 s per cm, 2.0 minus 4.6 times 10 to the power of negative 4 s per cm, 1.02 s per cm, and one result from the SPE, which is the SPE negative 5 equal to 0.47 ms per cm. This also to investigate the voltage stability as our studies. From the articles, show the 5 volt is the most highest voltage That means the most ionic conductivity that was recorded for all of the articles. Each articles will obtain different voltage stability. The lowest voltage stability started from 2.71 volt to 4.3 volt, and 4 articles obtained 4.4 volt, and also one article had 4.6 volt. They also have both same voltage stability between 1 and 3, which is 4.5 volt. From here, we agree to use the average value of both ionic conductivity and voltage stability as our main sources because it is more relevant and accurate. Regarding to our study, the best information is for article 1 and 4 and 3 because it's more clearly to understand.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Faris Lokman. Will explain about the methodology for this sodium polymer battery. For the first methodology, the electrochemical impedance spectroscopy scans from 100 mHz to 7 MHz of a cell with stainless steel electrolytes in the configuration of SS, DSPE, XSS were used to determine the DSPE RT ionic conductivities. The ionic conductivity was calculated using the formula I divided with RA, where I is the electrolyte membrane thickness, R is the boot resistance, and A is the contact area between the DSPE and SS. The LSV data collected using an SS DSPE XNA cell was used to evaluate the DSPE electrochemical window. The charge discharge voltage range was chosen at 2.5 until 4.1 volt to determine cycling stability. The next methodology is ionic conductivity was measured using polymer gel electrolyte membrane sandwich between two 1.24 cm per square cross-sectional area stainless steel blocking the electrolytes. A 10 mV alternating perturbation voltage was applied across the SS electrolyte SS cell configuration, and the real and imaginary impedance were measured over the frequency range 1 Hz until 1 MHz. Another methodology described that the management of electrolyte source of polymer matrix was used to improve the ionic conductivity in sodium ion conducting SPE, dry SPE ionic conductivity, and interfacial stabilities. Again, electrode materials are still falling short of RT sodium battery requirements. PPE or GPE with a portion of liquid bases have gotten a lot of attention lately because of their increased ionic conductivity. There is also another methodology where the ionic conductivity at different temperatures in the cation substituted and anion substituted was observed. A higher ionic conductivity as a result of its higher sodium ion concentration and larger unit cell. Last method is when the similar sodium or vacancy chemical composition are formed. The P2 type layer material has a higher ionic conductivity than the O3 type layer material. The high ion conductivity of sodium-based electrolytes also helps to improve battery performance. In the sodium system, the operating voltage was relatively high via the ferric ion or iron 4 redox without oxygen loss.
Number 4, result and discussion. From the research show the ionic conductivity have a relation with voltage stability to cycling the performance of material ion in battery. The study also said the polymer can increase the ionic conductivity through anode and cathode based electrolyte. This cycling voltammetry is the best technique to evaluate the electrochemical stability window (ESW) of any electrolyte system. ESW is defined as the working voltage range offered by electrolyte system during a cell operation. So figure 5a show the result from the analysis, which is A. Electrolyte cell configuration for evaluation of electrochemical stability window, and B. Sodium electrolyte cell configuration for confirmation of sodium ion transport in electrolyte. On close inspection of figure 5a, we found very small current value of the order of few microampere in electrochemical stability window region, which indicate absence of any unwanted redox reaction or water trace within the study electrolyte system. In order to confirm the movement of sodium ion, cyclic voltammetry study is performed using symmetric reversible cell configuration. The cyclic voltammetry shown in figure 5b indicate two peaks toward anodic and cathodic side, which further suggests the plating of sodium ion at anodic side and stripping of sodium ion at cathodic side. Hence, anodic and cathodic redox reaction are facile at sodium hydride electrolyte interface, indicating the movement of sodium ion from anodic to cathodic side and versa on application of a small voltage. Those electrochemical stability window of negative 4.4 voltage, which appear good from application point of view in sodium battery with evidence of plating or stripping of sodium ion at respective electrode. Many research have reported similar sodium ion movement using polymer gel electrolyte membrane and reversible sodium electrolyte system.
What is evident from this review is that there remains a broad range of opportunities and unexplored polymers that may show superior performance as SPE or GPE in sodium-ion battery applications. To the extent that sodium-conducting polymer electrolytes share many of research and on fully amorphous polymer electrolytes for SPE and GPE also remains scarce and present a fruitful area to pursue due to potential for enhancing safety aspect of particle SiB. In addition, LiB electrolytes based on the classic motifs PEO have seen extensive structural experimentation, the characteristic of lithium conducting ones. Many of the challenges are similar. Polymer electrolytes in which ion movement is decoupled from the movement of the polymer backbone in which the conductivity is not tightly linked to the glass transition temperature also hold promise. In addition, an important component of the conductivity is the interfacial contact between the polymer electrolyte and the electrodes, which is often poor in the form of side chains, copolymer, and end groups, which has so far taken place only in limited measure for sodium-ion batteries. These approaches are likely to be fertile ground for improvements and innovations in sodium-conducting polymer electrolytes in the near future. The promise of sodium metal batteries provides a dominant research direction for sodium-conducting polymer electrolytes due to the considerable advantage in energy density. These have overstayed of the art SiB and LiB. Organic polymer materials are directly made into flexible freestanding cathode and anode for sodium-ion with many advantages. Although flexible organic polymers for sodium-ion batteries are considered the most desirable green sustainable energy storage device of the future, however, there are still scientific and technical challenges that hinder their large-scale application. The inherent low electrical conductivity of organic materials greatly affect the performance of the battery. Sodium batteries built on naturally abundant elements have aroused intensive attention in recent years and are becoming one of the mainstream technologies for accessing rechargeable batteries with better economy feasibility compared to the contemporary lithium-ion battery. To further enhance the performance of PE-based sodium batteries, we tentatively suggest the following directions to be tackled in the future work. The case of intrinsically safe and highly conductive PE. This is our reference for our final year project. Thank you.